One of the most popular topics of conversation here at Mobile World Congress is perhaps inevitably 5G, with its promise of super fast throughputs. But what exactly is 5G? Or rather, what will 5G be? We spoke to the head of the UK's new 5G Innovation Centre to find out more.
In the sense that it is mobile communications as well as connectivity and control of other devices. It could be sensors, as smaller sensors, or the devices could be as big as a car or a train or a plane. So that's why it is difficult within the framework of the previous generation to define 5G. The previous generations, they always have to coexist with the future generation system. And 4G is going through evolution as 3G is going through different evolution as well. But what 5G will do, we expect that to be in the market by 2020, the first phase of 5G. And it should serve the market for at least 20 years, at least until 2040. And it will coexist with some of the previous generation systems, as well as the Wi-Fi system. And the main expectation requirements of the 5G is availability. It has to be, connectivity should be available despite where you are located. And for this, there is many systems will play their own role to complement each other to provide that connectivity. But obviously, cost effectively, it has to be done. We need to understand what user requires. And users don't always need broadband communication. They have a variety of different services. And the network should be intelligent enough to always provide sufficient rate and meet the requirements of the user. For this, the system 5G should be designed around a user and user's requirements and have a good understanding of the user rather than designing the network and all the technologies for the end device, but the person sitting behind the end device. And previous generation systems were designed for certain applications. And most of this system needs to be serving the market for at least 20 years. And we don't know in 5 years' time, 10 years' time, let alone 20 years' time, what market, what application will be dominant, what application will come. So what we should do in 5G, we should learn our lessons from previous generation system. Don't design it for a specific service or application, but design it for lower and lower and lower latencies, end-to-end latencies, lower and lower and lower energy consumption. Flexibility is very important. As I mentioned, we don't need always to have broadband communication. The system should be flexible enough to support narrowband, highly delay-sensitive applications, as well as broadband high-quality systems. So flexibility and evolvability of the network and the system is extremely important features. And once we have all these attributes in the 5G system, we can support wireless robots all the way to driverless cars in 2025 or 2030 when they are about to come out. One of the requirements of 5G is seamless connectivity across licensed and licensed XM bands. And there is a huge amount of licensed XM bands available. And Wi-Fi is a great technology, but it's not designed for high density of deployment. So the 5G air interface as well as the network architecture should operate seamlessly wherever the spectrum is available and whether it is licensed or it is licensed XM band. And that's how the Wi-Fi will be around because it's very inexpensive technology. It'll be around for many years to come. But one of the objectives of the 5G is come up with the technologies for high density of the small cells. And those small cells where we need high capacities, we need to move across licensed and licensed XM band. Obviously, we're looking at different waveforms for different air interface, which is flexible enough that it can support narrowband, like machine-type communication, Internet of Things, as well as a broadband communication system. And another important aspect of the air interface is, whether we like it or not, the spectrum is going to be extremely fragmented. The ability of the waveforms, the new air interface, to integrate and aggregate different parts of the spectrum is extremely important. So we need to take a holistic approach to 5G. Air interface is only one part of the whole system. Effectively, air interface radio part is about 20–30% of the whole system. The rest of the network, the fixed part of the network, is 60–70%. And if you want to have end-to-end and round-trip delays of 5 milliseconds or lower, or 1 millisecond, it will affect the fixed part, the radio part, network architecture, radio access network, and all those aspects. So our approach, as I said, special generation, we need to take a special look at end-to-end system and come up with the appropriate technologies. Software-defined networks and network function virtualization are important functionalities. It would allow evolvability of the platforms for the new functionalities that we don't know what it's going to be. And once we have this sort of infrastructure and the platforms, then it's easier to evolve and integrate for different applications and launch new applications and services as well. I hope 5G is not going to end up with just yet another air interface, and that's the end of the story. Otherwise, we are not going to meet the requirements and the application that we expect for connected society, connected other vertical industries. We will not be able to achieve that.